So relational data models have different aspects and different terminology that you should know. We'll use this table here as an example to explain what these are. The first one is attributes, and think of this as the columns of your table. And basically, these just describe the meaning of the data below. So here we have name, GPA, credit hour, and major of the students. Next up are tuples, and these are the rows of your table. They're also called relational instances. And the data inside are called components. So keep in mind there's one component for each attribute inside a tuple. And the entire relation is defined by its schema, which we are titling students. The way you define this is by writing the title, parentheses, and then your list of attributes you want inside of your schema. The order of these attributes is important because it defines a relation's standard order, and I'll explain why that's important in a minute. And this is the generic way of defining a schema that we'll use in relational algebra a little bit later. Databases can have more than one schema. The set of schemas is the relational database schema. And once again, remember that tuples can only have one component for each attribute. So if we have a database movies and we want to know what actors are in the movie, we cannot have a set of actors for each movie. We have to create a separate table that hosts the actors and the movies. And this is because of the domain of the attribute. So think of it as kind of like the attribute's data type, except it has to be atomic, which means it can only be numbers or letters. So you can't have arrays, lists, or anything like that. To define what the domain should be, you simply just write the attribute name, put a colon, and then write if it's a string or an integer. And for equivalency, keep in mind that you can reorder the columns or the attributes of a relationship and it stays equivalent. The relation is equivalent to one another. But you have to make sure that you also reorder the tuples that go with it to maintain the standard order. And the reason for this is because if you have a tuple without the attributes there to define it, you still know what the components mean because of the standard order. Another note is we expect our tables to change. Take this table from the example at the beginning. GPAs are probably going to change over the course of a student's career as well as majors, and we may even add another student to tables. This is all fine. We do not expect the schema to change. It's not that it's not possible for it to change, it's just that you want to minimize it as much as possible. And the reason being is it's very expensive. Think about it this way. Say we want to add a minor column to this table. Some people may have minors, some people may not, which can cause issues. Also, we may have a million entries in this table, and that's very expensive to update every single one of them. Alright, I know this video has been getting long, but there's one more thing to talk about, and that is keys. Keys are what define an instance. So that means if you know these components of that instance, you can get the rest of the components inside of that same instance. To define what the keys are in a schema, you simply just underline the attributes that are the keys. So for this instance, we can underline name and maybe major to say that that will give us a student. Now you may be seeing an issue with this. What if we have more than one student with the same name and same major? Well, then we create a synthetic key known as ID. Most of you guys probably have a student ID, and this is one that is made up so we know it's completely unique and will always give us the same student. Using the example from the book Movies, we can define the keys as title and year. This is saying that we're making an assumption that no movie will have the same title and same year. There's many movies that may have the same title and many movies that may have the same year, but we're saying that these are going to be unique with both of them. This is a real world key, and it can be dangerous because it doesn't always hold true because you don't have control over it.